Antibody-drug conjugates are an expanding class of biopharmaceuticals, in particular for cancer treatment, and at the same time they are challenging to characterize. So there are critical quality attributes like the charge variant distribution or the drug antibody ratio and the distribution across the linker sites. And typically you determine this with cation change chromatography, either in salt or salt gradient or pH gradient, or you do a hydrophobic interaction chromatography, so outsalting chromatography. And all these techniques are difficult to combine with mass spectrometry, but mass spectrometry is very important for annotation and further identification.
What was your main research question and how did you go about answering it?
As I said, the main research focus was more on the instrumental side, how we can combine the separation mode with the mass spectrometry. And the approach was using a multi-hard cut, 2D-LC, where we cut the fractions from the MS non-friendly method and we dissolved it, in this case based on size exclusion. That means in the size exclusion chromatography of the second dimension, the larger molecules are excluded, and without the disturbing salts, they run into the mass spec, and the salts come later and can be diverted to waste. So much the idea of it.
Was there anything in your research that surprised you or stood out as a key insight?
It was the extent of the challenges to get reasonable peak shapes in the second dimension, because a downside of size exclusion chromatography is you do not stack or focus something on the second dimension column, and without that capability you have to be very careful what you transfer to the second dimension. So for instance, we have identified that it only works in a backflush mode. If you do a forward flush out of your fractionation loops, you mess up everything. That was kind of surprising and important finding.
And how could your findings be useful for others in the field or even in real-world applications?
Yeah, first of all, this critical attribute characterization is an important real-world application, because these CQAs are absolutely critical for efficacy, for stability, safety of these drugs. So we propose a method that is ready to use. And at the same time, somebody looking at our results will be aware of where the challenges are when you transfer such fractions into an SEC. So the little tips and tricks, how you combine the dimensions, the diameters of the column, and how you do the transfer. Nobody else has to run into the same issues. They will see it from our results.